This is a video on using calculus to sketch a graph. The question states, sketch the graph of y equals 2x over x minus 1. So I'm going to start by finding my intercepts. And that is, if y is 0, then x is 0. So I get 0, 0 for both the x-intercept and the y-intercept because the origin includes both. Now let's find the asymptotes. For the vertical asymptote, I set the denominator equal to 0, so x is equal to 1 is my vertical asymptote. For the horizontal asymptote, I take a limit as x approaches infinity, and if I divide top and bottom by x, I get 2 over 1 minus 1 over x, and that approaches 2 as x approaches infinity. So my horizontal asymptote is y equals 2. Now let's see if there's any other critical points. If I take a derivative, I get negative 2 over x minus 1 quantity squared, and that's never 0 because the numerator is negative 2. So I get no extrema. Now let's look for inflection points. If I take a second derivative, I get 4 over x minus 1 cubed, and that also is never 0. So I get no inflection points. So far all we have is that the graph passes through the origin. We have a vertical asymptote at x equals 1 and a horizontal asymptote at x equals 2. Let's look to see what the shape of the graph is by creating a table. So we only have to deal with less than 1 and greater than 1 because that's our only critical point at x equals 1. So when x is less than 1, if I plug it into the first derivative is negative 2 over something squared. That's always negative. So in particular, the sign of f prime of x is negative in both intervals x less than 1 and x greater than 1. On the other hand, if we look at f double prime of x, if x is less than 1, then x minus 1 is negative, and negative number cubed is negative, 4 over that is negative, so I get a negative for f double prime of x to the left of 1. If x is greater than 1, then x minus 1 is positive, and everything is positive. So I get a positive sign to the right of 1. So now let's look at the shape. To the left of 1, we're decreasing and concave down. So that means it's going downwards and getting steeper. To the right of 1, it's decreasing and concave up. So that means it's going downwards, but it's leveling off as I'm getting larger. So now that we have all the information we need, we can sketch the graph. I get a vertical asymptote at x equals 1. I get a horizontal asymptote at y equals 2, and it passes through the origin. To the left of 1, it has this shape, and to the right of 1, it has this shape. And there's my graph. I'm done with the problem.